Hi, I'm just going to go over a few things for Smarter Balance review, just general test prep review. Just going to dive right in with repeating decimals to fractions. Before we dive into repeating decimals to fractions, you should already know how to convert just a regular decimal to a fraction, right? So if I have if I have 0.25, right? That's the 10th place, that's the 100th place, that's really important to know. And I'd get 25 over 100 because it's out of 100. And then I'd simplify it to 1 over 4 because I can divide both by 25. Very, very simple, but when it's repeating decimals to fractions, it's a little bit more challenging and a little bit more tricky. So we're going to go over it step by step. So if I want to convert 0.4444 or 0.4 repeated into a fraction, what I would do is if I will have 0.4 repeated, right, which is the same thing as saying 0.444 ... what I would do is I would see how many places it takes for the number to be repeated, right? So in this case, it takes, right, if I'm moving the decimal over once, I still see another 4. So I only need to move it over one place. Let's give another example. So if I have like 0.31, 3131, how many places does it take to move the decimal? To get a repetition? That's twice. So in this case, this is moved over once. So that's the 10th place. So I need to, each time I move a decimal over, I'm multiplying by 10. So in this case, I'll have to get the repeating, it would be moved over one place, so it would be times 10. So I have x is equal to 0.4 repeated, or 0.444 ... And then to get it to repeat, it's 10x is equal to 4.44 ... or 4. Let's add another 4 in there. So what I'm going to do to solve this is I'm going to put these together. 10x is equal to 4.444, and then I'm going to get minus 1x is equal to 0.444. That means I'm going to get 9x is equivalent to, I've gotten rid of all my decimals, 4. Now I can solve this. Divide by 9, divide by 9. X is equal to 4/9. So there is how I deal with a repeating decimal. Let's do one more together. The next one would be 0.34 repeated as a fraction. So if I wanted to write 0.34 repeated as a fraction, what I would do is first I would say x is equal to 0.34 repeated, or I would say x is equal to 0.34343, or let's just do that twice. Now, how many times does it take to repeat the pattern? I need to go over 2 decimal points. So 1, 2 until it repeats, or 1, 2 until it repeats, because it's going 34, 34, 34. So if I go over 2 times, each one is multiplied by 10. That's going to be times 100. So it's going to be 100x is equal to 34.34. Now, And then I always want to match up how many decimals there are. So I have 100x is equal to 34.34, and 1x is equal to 0.3434. All right, I always want to have the same number of, and remember, I can always add more 3/4s, but I don't need to. That's why I just have these dot, dot, dots. I want to have the same number of numbers behind the decimals. I'm going to get 99x is equal to 34. Now, if I solve this, I'm going to divide both sides by 99. Divide both sides by 99. X is equal to 34 over 99. All right, so that's how you solve for a repeating decimal and turning that into a fraction, right? In the math packet that I gave you, there are a few problems like this. You can definitely consult this video to help you with those. Next thing I'm going to dive into is just a little bit of exponents review. I'm going to be all over just because we are doing a bit of smarter balance review. So with smarter balance review, you want to just make sure you're covering a whole host of different topics. So with exponents review, there are 3 major rules. If you get these 3 rules down for exponents, you can never get an exponent problem wrong. The first rule is the bases will stay the same. All right, so in this case, you have to know what a base is. A base is something that is attached to an exponent. So in this case, it's the a, the b, the c. So those are going to be your bases. Your bases will always stay the same. 2, your exponents will follow the rule. So that means, like if you have a to the 3rd times a to the 4th, that's not going to be a to the 12th. It's going to be a to the 7th, because there's a rule of when you do something like this, that I actually add the exponents, right? We can go into the reasoning behind it, but if you've been working with me most of the year, you should have that reasoning down. So just because this is a wrap-up video, we're not going to be going into the reasoning behind it. So exponents going to be following the rule. For multiplication of exponents, you actually add them. Division, meaning you would subtract. For the power rule, you would multiply. All right, so exponents would follow the rule. Number 3 is coefficients follow the operation. So if you have coefficients following operation, what that means is you're going to, if I have division as an operation, like I have in this particular problem right here, I would divide. If I have like 3x squared times 2x to the 4th, I would multiply my coefficients. 3 is a coefficient, 2 is a coefficient, and I would get 6x to the 6th. All right, those 3 rules will help me with any exponent problem that I would have. So let's attack this problem that we have here. 6a to the 7th, b to the 8th, c to the 6th, over 3a to the negative 4th, b to the 4th, c to the 11th. So with this particular problem, what I would do is, well, first let me deal with I know I have these rules out of order, but let me deal with the coefficients. The 6 is a coefficient and 3 is a coefficient. It's going to follow the operation. So 6 divided by 3 is 2. And then I have a to the 7th. Well, I know my bases are going to stay the same, so I'm going to have a, b, and c. Now let's see what the exponents are. So with division of exponents, I actually subtract my numbers. So 7, most people would say 7 minus 4, but this is actually going to be 7 minus negative 4, which is going to give me 11. So 2a to the 11th. b, I have 8 minus 4, which is 4. b to the 4th. c is going to be 6 minus 11, which is going to be negative 5. So 2a to the 11th, b to the 4th, c to the negative 5th. Now, this could be, I mean, this is an answer that's correct, but if you, when you're dealing with exponents, you often do not want to have negative exponents in the numerator, right? So 2a to the 11th, b to the 4th, and c to the negative. Well, actually, you just don't want to have negative exponents. So what you do whenever you have a negative exponent is you can actually move the exponent and the base to the denominator. All right, so your final answer would be 2a to the 11th, b to the 4th, over c to the 5th. And that would make that positive. All right, let's try another division problem. I have 6a to the 5th, b to the negative 3rd, n to the 5th, over 10, a to the negative 6th, b to the negative 4th, n to the 3rd. Now you can clearly try this on your own. You can pause the video and try the problem, but I'm going to go through, and after you can definitely check. First thing, identify what's the coefficient, what's the base, what's the exponent. 6 is a coefficient, 10 is a coefficient, a is a base, b is a base, n is a base. So what I would do here is deal with my coefficients first. First thing is I see it's the division problem. No fear because it's a fraction. All you need to do is just simply simplify this problem. So I have 6 over 10, and that would be 3 over 5. Okay? I have a to the 5th, b to the negative 3rd, n to the 5th. Let's deal with this. A to the 5th, sorry, you're going to have your a, b, and n. Those are all going to stay the same. With the 5 minus negative 6, right, because it's division, so I'm going to subtract 5 minus negative 6. So a to the 5th minus divided by a to the negative 6. I'll have 5 minus negative 6. That's going to turn into plus. It's going to be 11. A to the 11th. Negative 3 minus negative 4. Well, that's once again going to be a flip situation. Positive 1. N to the 5th divided by n to the 3rd. So I'm going to do 5 minus 3 is equal to 2. N squared. Everything is positive here. I don't need to write b to the 1st. So I can write 3 over 5. A to the 11th, b, n squared. So that would be your final answer. All right. Going to quickly review the power rule here. So there's a big difference between multiplying exponents and the power rule. So multiplying exponents versus the power rule. So let's do this. Multiplication of exponents is like if I have 4 to the 3rd power times 4 to the 5th power. Well, in this case, this is going to be, in this case, it's going to be making this 4 times 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 4. 1, 2, 3, 4, 5, 6, 7, 8. I add the exponents. I could have also have written it as a to the third times a to the fifth, or a to the sixth, right? There's parentheses here. That still just means multiplications. That's just going to mean adding my exponent. Now, there is a bit of a difference between multiplication of exponents and the power rule. And I'm going to get into that difference in 1 second. With the power rule, it looks similar because there's going to be parentheses, but we have a to the third to the sixth power. Let's take that. Actually, let's make it a little bit simpler so I can explain it. I have a to the third to the fourth power. What this is saying, notice it looks similar to this. They look very similar, but there's a very big difference. With the power rule, what this is saying is I'm going to do a to the third times a to the third times a to the third times a to the third. I'm doing a to the third 4 times, which is going to give me a to the 12th. Okay? So if I have r to the third to the 9th power, it's not going to be r to the 12th. That's going to be r to the 27th. Now it gets even a little bit more tricky when I start adding in my coefficients. Suppose I have 6 r to the 5th, b to the 2nd, all to the 4th, all to the 3rd power. Well, one thing that's really nice about exponents and things in general is that you can always add the number 1 and it will stay the same. And I like to think about the power rule in these cases just like the distributive property. So what I would do is this would go to everything. It would go to here, it would go to here, and it would go to here. So it would be 6, not to the first power, but it would be 6 to the 3rd power, r to the 15th power, b to the 6th power. Now, when you solve that, you could leave it like that, but in most cases, they're going to want you to know what to do with that first number. So you have 6 to the 3rd power, which is going to give you 6 times 6 times 6, which is 216 r to the 15th, b to the 6th. All right. So there is a pretty significant difference between the power rule and just multiplication of exponents. So if I gave you a problem like this, the question is this a power rule question or is it a multiplication of exponents question? All right. So let's look at it for a second. Well, a multiplication of exponents question would can still have parentheses. That's often a misperception, right? I could have 5a to the 3rd, b to the 2nd, times 2a to the 3rd, b to the 5th. This would be a multiplication of exponents. This, however, is not a multiplication of exponents question. This is a power rule question. And how do we know that? It definitely has those parentheses, but at the end, it has this exponent. And what this exponent is saying is that I want to take this 2 and have it go to every single thing. And notice I put a 1 by that 5. So I'm going to have this 2 go to the 5, go to the 4, go to the negative 8, and go to the 3. So this is going to be 5 to the second power, k to the 8th power, L to the negative 16 power, M to the 6th power. When I get through that, that is going to be 25 k to the 8th, L to the negative 16, M to the 6th. The last step of this, which would be 25 k to the 8th, L to the, now I can put the L on the denominator, k to the 8th, M to the 6th, over L to the 16th. Going to make that positive. Why? Because I can move things to the denominator to make them positive. Now, when I'm just going to do a few more problems, and then we can call it quits on this. What I'm going to do here is try this problem. This one, I have to analyze and see what type of problem this is. And am I dealing with bases? Am I dealing with coefficients? Am I dealing with exponents? All right. If I have a to the 5th, we all know that this a is a base. If I have 3a to the 5th, the a is the base, the 3 is the coefficient. But what if I just have 3 to the 5th? That sometimes tricks people. Remember, a base is going to have the exponent attached to it. So this is going to be your exponent, and this is going to be your base. So in this, I'm not dealing with coefficients whatsoever. I'm only dealing with bases and exponents. So let's go through this problem and see how I can deal with that. So if I have 3 to the 5th times 3 squared times 4 to the 2nd over 3 to the 3rd times 4 to the 5th. There's going to be two types of things I'm going to be doing. I'm going to be the multiplication of exponents, which I really add them, and division of exponents, where I really subtract them. So here, it's going to be 3 to the 7th times 4 squared over 3 to the 3rd times 4 to the 5th. All right, now how would I go about solving this? I would do 3 to the 7th divided by 3 to the 3rd. That's going to be 3 to the 4th. And then I'd have 4 to the 2nd divided by 4 to the 5th. And that's going to be 4 to the negative 3rd. So I do have 3 to the 4th times 4 to the negative 3rd. Unfortunately, that's none of my answer choices. So what do I do in that situation? I will move my 4 to the negative 3rd to the denominator to make sure that my exponent is positive. Do I see that anywhere? I do. Hopefully you understand this question. I believe this exact question is in the packet that I gave you. Hopefully, well, you just got a free question, but hopefully it makes some sense. We're going to do another question like that. Which expression is equivalent to the following? If you can get a question like this, you definitely understand exponents relatively well. Once again, I'm just dealing with bases and exponents here, no coefficients, all right? But if I have 2 to the 4th times 3 to the negative 10th, 3 squared to the third times 2 to the negative 2. I'm going to have all the different things here. I'm going to have power rule. I'm going to have division of exponents. I'm going to have multiplication of exponents. Obviously, as I said before, you can definitely pause me and try the problem on your own. In fact, I'm hoping that's what you're doing. But let's try this problem. The first thing I want to do is I want to deal with the same bases. So 2 and 2. This is going to be division of exponents. So it's going to be 2 to the fourth divided by 2 to the negative second. That's going to be 4 minus negative 2, which is equal to 6. So I have 2 to the power of 6. And then I'm going to deal with the second part, which is here, 3 to the negative 10, and then this. If I do this, that's going to be 3 to the 6th power, right? Because that's the power rule. And I have 3 to the negative 10 divided by 3 to the 6th power. 10 minus, negative 10 minus 6, which is going to be negative 16. So I'll have 2 to the 6th times 3 to the negative 16. Is that an answer choice? Always want to check that. It is. I could have also written it as 2 to the 6th over 3 to the 16th. All right, that's going to be the first video that we did. Hopefully you guys understand what's going on. Definitely here to answer any questions. You can email me. Writing my email here. You can call me. Most of you have my number. If you have any questions, just make sure you're working through your packet as you're watching these videos. I might also make videos of the packet questions as well. All right, that should be it.